Imagine looking up at the night sky, a seemingly infinite expanse of stars, planets, and galaxies stretching farther than the eye can see. Among them, hidden in the inky darkness, lies a tiny red dot, Proxima Centauri. It's the closest star to our own sun, a cosmic neighbor only 4.24 light-years away. But what if I told you that the James Webb Space Telescope might have uncovered something extraordinary there? What if it found hints, no, potential signs, of life on a planet orbiting that very star? Could this be the moment humanity has waited for? The moment we've long imagined in science fiction and dreams alike? Stay with me, because what we're about to explore could very well change how we see our place in the universe. The James Webb Space Telescope, or JWST, is the most advanced telescope humanity has ever built. Its massive golden mirror and suite of sophisticated instruments allow it to peer into the depths of space like never before. But it's not just distant galaxies or the early moments of the universe that JWST is exploring. It's also looking closer to home, at stars like Proxima Centauri and the planets that orbit them. One such planet, Proxima Centauri B, has been the focus of scientists and dreamers for years. This rocky world sits within the habitable zone of its star, a region where temperatures could allow liquid water to exist on the surface. And as we know, where there's water, there's a chance for life. But until recently, all we had were hopes, models, and theories. Now, thanks to JWST, we may be one step closer to answers. Imagine the possibilities. A planet bathed in the dim red glow of its parent star, with oceans, rivers, or even microbial life lurking just below the surface. What if JWST's instruments could detect the fingerprints of life in the atmosphere of Proxima Centauri B? Molecules like oxygen, methane, or even water vapor could point to biological processes happening on the planet. And that's exactly what scientists are hunting for. This isn't just about science, it's about the existential questions that define us. Are we alone? Or is life in some form scattered throughout the cosmos, waiting for us to discover it? Before we dive deeper, if you're as fascinated by the mysteries of the universe as I am, take a moment to subscribe to Space Exploring and hit the like button on this video. Your support helps us bring you the latest discoveries and the most exciting stories from the frontiers of space. Plus, when you subscribe, you'll never miss a chance to learn about groundbreaking moments like this one. So go ahead and join our community of space enthusiasts. We're on this journey together, and the best is yet to come. Now let's talk about what makes Proxima Centauri B so intriguing. This planet is roughly 1.1 times the mass of Earth, which means it's similar in size and likely rocky. It orbits its parent star every 11.2 Earth days, meaning a year there flies by in less than 2 weeks. Its star, Proxima Centauri, is a red dwarf, much smaller and cooler than our Sun. While this means Proxima Centauri B is much closer to its star than Earth is to the Sun, the planet still falls within the habitable zone due to the star's lower energy output. But living near a red dwarf comes with challenges. These stars are known for their powerful solar flares, which could strip a planet's atmosphere or make the surface uninhabitable. Yet, recent observations suggest Proxima Centauri B might have a magnetic field strong enough to protect itself, much like Earth's magnetic field shields us from solar radiation. Could this mean the planet is more hospitable than we'd imagined? The James Webb Space Telescope is uniquely equipped to investigate questions like this. Its ability to analyze light passing through a planet's atmosphere is nothing short of revolutionary. By studying the starlight filtered through Proxima Centauri B's atmosphere during a transit, when the planet passes in front of its star, scientists can determine the chemical composition of the air. If JWST detects molecules like carbon dioxide, water vapor, or ozone, it could be a game changer. Even more exciting would be finding biosignatures, gases that are hard to produce without life. Imagine the moment when the data comes in, showing clear evidence of methane alongside oxygen, a combination that almost always points to biological activity. But the hunt for life isn't straightforward. The data JWST collects is complex, requiring painstaking analysis and interpretation. False positives are a constant concern. For example, certain geological processes can produce methane without life being involved. Likewise, oxygen could be generated by photochemical reactions rather than biological ones. This is why scientists cross-check their findings using multiple methods, and collaborate across disciplines to rule out alternative explanations. It's a meticulous, rigorous process, but one that brings us closer to the truth. Beyond Proxima Centauri B, there are other intriguing possibilities in the same star system. Proxima Centauri also hosts another planet, Proxima Centauri C, which orbits farther out. While it's unlikely to be habitable due to its distance from the star, it could still offer valuable clues about the system's history and dynamics. And let's not forget about Proxima D, a smaller planet discovered even closer to the star. Each of these worlds adds another layer of complexity and intrigue to the system. What secrets might they hold? Could life exist in forms we've never even imagined, adapted to conditions we'd consider extreme? As we wait for more data from JWST, it's worth reflecting on the bigger picture. Discoveries like this don't just advance our scientific understanding, they ignite our imagination. They make us wonder about the possibilities of interstellar travel, of one day reaching Proxima Centauri ourselves. While it's still far beyond our current technological capabilities, missions like Breakthrough Starshot are already exploring ways to send tiny, high-speed probes to this nearby star system. Such missions could take decades to reach their destination, but the payoff would be immense. Imagine getting up-close images of Proxima Centauri B, or even direct measurements of its atmosphere. It's the kind of science that feels like science fiction, but is slowly becoming reality. Of course, the implications of finding life, even microbial life, on Proxima Centauri B would be profound. It would suggest that life is not a rare accident, but a common occurrence in the universe. It would mean that the cosmos is teeming with possibilities, each star a potential host for worlds brimming with life. And what if we found intelligent life? How would we communicate? What would we say? The discovery would raise as many questions as it answers, reshaping our understanding of existence itself. For now, we're left to wonder and to wait. But the wait is part of the excitement. Every new observation, every piece of data from JWST brings us closer to understanding our place in the cosmos. And as we continue to explore, we're reminded of how far we've come. From Galileo's first telescope to the James Webb Space Telescope, our journey of discovery has been nothing short of remarkable, and it's only just beginning. So, as we look to the stars and dream of what might be out there, let's remember that the search for life is also a search for ourselves, for who we are and what we might become in a universe full of possibilities.